I am AS Kiran Kumar, former chairman ISRO. Welcome to LifePage, and I am going to talk to you about space technology. Let me give you a brief introduction of myself. I studied my schooling in Hassan of Karnataka, where I did up to pre-university, and then from there on I moved to Bangalore for physics honors degree in National College, and then after MSc I did my Master of Technology in Physical Engineering from Indian Institute of Science. I joined Space Applications Center, ISRO, and I have been working with them for the last almost 44 years. Space technology is basically a capability to build satellites and instruments and take them to space and make them work from there for various application activities we have in mind. This technology involves building rockets, building satellites, building space stations, building even humans in space. As you can visualize, space technology involves a large number of diverse activities, and naturally being familiar with multidisciplinary knowledge helps a great deal. And multidisciplines here starts from physics, chemistry, mathematics, computer science, mechanical engineering, thermal engineering, structural engineering, and you name it, the entire set of learning processes. Even biology and zoology is also important in this, because in terms of the technologies involved, you are dealing with humans, you are dealing with application activities. So discipline wise, practically you can say the whole set of learning skills that one encounters in the universities would be important here. But at the same time, what is important for an individual will be having a width of a large number of disciplines, but depth in one particular area can make that person strong in dealing with space technology activities. Space technology, as you can visualize, is also an activity which is fraught with a large number of risks. Risks because you are venturing into areas sometimes unknown or sometimes less known. And in this, there are large number of engineering judgments which are made, and these engineering judgments also come with it the probability of failures, or certain activities may not succeed or may not perform the way you are initially visualizing it. That means you should be ready to take certain risks, and with this risk comes failures, and dealing with failures should be one of the key skills that you need to develop. Today, in terms of people working in space technology across the globe, you can see that there is a tremendous amount of awe, respect and recognition for people who make things happen from space, whether it is the people who have built the launch vehicles, people who have built the rocket, or the satellites, or even the instruments from which observations are being made, the scientists, the technologies, and also the humans who have gone into space. All of them derive great amount of satisfaction because of the respect they get from the society. The challenge is to visualize what is required to be done and make it happen. And in this case, unlike what we develop for things on ground, the failure rates makes it very difficult, because on ground, if you encounter a problem, you can replace that part and rework on that. Whereas here, when you are sending something to space, if the launch vehicle fails, then everything that you have built in that has gone. You have to do the whole thing again. Something else could fail. So the problems of this kind of risks are many, and so the whole process of the visualizing how to make things happen under conditions which are many times not known to you to start with, will have to be dealt with, and that's how it's both challenging as well as difficult. a day in the life of a space technologist, if you look at, of course, definitely it depends on the time, a particular time. For example, if it is on the launch day, it will be different. If it is a mission getting into orbit, it will be different. Or if you are looking at maneuvering a satellite into the orbit, so it's different on different day.